Asymptotes are identified by taking a limit. In other words, a function approaches an asymptote because the limit of the function is approaching, but not reaching, a finite value, or even an infinite value. The rational functions provided in this video provide great examples for how these asymptotes come about. Horizontal asymptotes are found by taking the limit as x approaches infinity. This is also similar to slant asymptotes. So looking at f of x, let's take the limit as x approaches infinity of 2 over x plus 3. To see where this is heading, I'm going to approximate this by plugging in a pretty large number for x. Let's say 1,000. This becomes 2 over 1,000 plus 3, which is approximately equal to 0.002. So I can see as x is getting pretty large, this function value is getting pretty small. Now as x is getting larger and larger, this value will be getting smaller and smaller, so small that it will approach 0, but it will never quite reach 0. So that means the horizontal asymptote for f of x is equal to y equals 0. This is similar for x approaching negative infinity. 2 over a number approaching negative infinity will also equal 0. However, it's going to be approaching from a negative direction. We'll see that on the graph in a moment. Let's look at g of x and take the limit as x approaches infinity of 2x minus 1 over x plus 3 to check its horizontal asymptotes. This one has a numerator going into infinity and a denominator going to infinity. We don't quite know what that means yet, so you want to rewrite this algebraically by multiplying numerator and denominator by 1 over x. This will reevaluate the limit as x approaches infinity as 2 minus 1 over x all over 1 plus 3 over x. Now the 1 over x as x goes to infinity, this is approaching 0. The 3 over x as x goes to infinity, that is also approaching 0. This limit for g of x is becoming 2 minus a number getting closer to 0 all over 1 plus 0, getting closer to 0, which equals 2. This means the horizontal asymptote for g of x is y equals 2. Similarly for x approaching negative infinity, think of the 2 from the numerator going in a negative direction divided by the 1 from the denominator going in a negative direction, where the negative divided by negative cancel and give you 2. You can also relate this back to a pre-calculus concept where if your degree of your numerator and denominator are the same, you take the ratio of the coefficients. That's another way to see where the 2 divided by 1 comes about. Let's take a quick look here. Here's f of x in our upper right corner, and notice how the horizontal asymptote is y equals 0. So as x approaches positive infinity going to the right, the function is approaching 0 but in a positive direction. As x is approaching negative infinity to the left, the function is approaching 0 but in a negative direction, meaning it's coming from below. Here's g of x, our horizontal asymptote's y equals 2. And notice as x is going to positive infinity, we are approaching y equals 2. It is from a negative direction. And then the left, it's also approaching 2, but in a positive direction. So we have the same horizontal asymptote on each side. That's what's important here. Now let's take a look at h of x. We have this one started out for us, which looks like infinity over infinity. So here's our rewrite step, where you multiply by 1 over x to numerator and denominator, and I recommend always taking the highest degree term from the denominator, which is x, so it's equivalent to dividing numerator and denominator by x, the highest degree term of the denominator. That rewrites the limit as this last step here. Notice as x goes to infinity, these two terms are heading to 0, so that this limit as x approaches infinity of 2x plus 1, that's heading to positive infinity. That means we have no horizontal asymptote. In fact, these y values are heading to infinity. That's because we have a slant asymptote. So to find a slant asymptote, let's take a look at this division algorithm if you're familiar with that. We have this already set up for us on this page right here. Here's the division algorithm, which provides us with 2x minus 5 as your quotient, and then your remainder 14, you add your remainder over your divisor. If you took the limit of this result, you would have 2x minus 5, which is going to infinity, but according to that linear curve, where the 14 over x plus 3 would be heading to 0 as x goes to infinity. So 2x minus 5 would be your slant asymptote, which means your function should be heading somewhere along this diagonal slanted curve right here.